I am R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this lecture series, we are going to discuss the topic of Karnaugh Map minimization, and this is for gates and minimization techniques. And why Karnaugh Map minimization? K-map simplification technique is simpler and less error prone when compared to the method of solving the logical expressions using Boolean laws. And its main purpose is to simplify Boolean algebraic expression. So previously we have discussed the minimization techniques using Boolean laws and theorem. It involves many theorems and laws so that the minimization becomes difficult. So that the simplest technique we are going is the Karnaugh Map minimization technique. And it was first introduced by Dr. Maurice Karnaugh in the year 1953. It is also simply called as K-map. So this Karnaugh map is a pictorial method of grouping together expressions with common factors and then eliminating unwanted variables. Karnaugh map uses the following rules which simplify the algebraic expressions by grouping together adjacent cells containing ones. So the first rule we see is the groups may not include any cell which contains 0. So in the left hand side diagram, a 0 and 1 is combined and it is wrong. Right hand side diagram, grouping is done only for the ones. So we should always group ones, not 0. And groups may be horizontal or vertical, but it should not be diagonal. So the left hand side diagram contains of diagonal grouping, it is wrong. So the right hand side diagram is the right diagram. And the third rule is the groups must contain 1, 2, 4, 8 or in general 2 power n cells. If n is equal to 1, the group will contain 2 ones, since 2 power 1 is equal to 2. If n is equal to 2, the cells are 4, that is 2 power 4 is equal to 2 power 2 is equal to 4. And each group should be as large as possible. So we have to try for grouping maximum number of ones. And the fifth rule, each cell containing a 1 must be at least in one group. So sixth rule, groups may overlap. So we can group ones which can be overlapped. So the seventh rule we see is groups may wrap around the table. The leftmost cell in a row may be grouped with the rightmost cell, and the top cell in a column may be grouped with the bottom cell, as in the diagram. So there should be as few groups as possible, as long as this does not contradict any of the previous rules. And the Karnaugh map, there are many type of variables Karnaugh map available. One is 2 variable Karnaugh map, 3 variable, 4 variable and 5 variable. So Karnaugh map, the 2 variable which consists of 4 cells, because we know that the formula for calculating the number of cells of a K-map is 2 power n, where n is the variable. So for 2 variable K-map, 2 power n, it is 2 power 2 is equal to 4. So the K-map contains 4 cells. There is one possibility of grouping 4 adjacent minterms. The possible combination of grouping 2 adjacent minterms are m0, m1, m2, m3, m0, m2 and m1 and m3. So next is the 3 variable Karnaugh map. The number of cells in 3 variable Karnaugh map is 8, since the number of variable is 3. So here there is one possibility of grouping 8 adjacent minterms, and we have other possible combinations are available like m0, m1, m3, m2, m4, m5, m7 and m6 etc. And Karnaugh map 3 variable diagram. So we have column wise 1 variable, row wise 2 variables. So the cells values are in the top 0, 0, 0, 1, 1, 1, 1, 0 for columns, and rows, since it is single variable, the variable value may be 0 for first row, and the second row it is 1. And next is Karnaugh map for 4 variables. The number of cells in 4 variable K map is 16, 2 power 4, since the number of, and the column consists of, there are 4 columns and 4 rows, so totally 16 cells, and the values for the midterms are designated from M1, M2, M0, M1, next is M3, and the last is M2. And M4 second row consists of M4, M5, M7, and the last is M8. And the third row M12, M13, M13 and 14. So last row is M8, M9, M11 and M10. So Karnaugh map for 4 variables, there is only one possibility of grouping 16 adjacent minterms. So here R1, R2, R3 and R4 represents minterms of first row, second row, third row and fourth row. Similarly, C1, C2, C3 and C4 represents minterms of first column, second column, third column and fourth column, etc. So there are many possible combinations are available. And last, there is a 5 variable Karnaugh map. So the number of cells in 5 variable Karnaugh map is 32, and since we have the number of variable is 5. So 5 variable Karnaugh map consists of 2 4 variable K maps. One is for the 5th variable value v is 0 and v is 1, and 2 rows, 2 digit row value, 2 digit column value, since it has 4 rows and 4 columns. So 0 0 0 1 1 1 1 0 as usual, and at the column wise it is 0 0 0 1 1 1 1 0. Next is 5 variable Karnaugh map. There is a possibility of grouping 32 adjacent minterms. There are 2 possibility of grouping 16 adjacent minterms, that is grouping of minterms from M0 to M15 and M16 to M31. So totally 32 minterms we can group, and if v is equal to 0, then 5 variable K map becomes 4 variable K map. So in K map there is one limitation. We can do K map only for 5 variable Boolean expressions. So if we go for more than 5, we have to go for any other methods. And assessment, advantages of K map. We know it is very simplest error prone method when compared to the simplification method using Boolean laws and theorems. And the second question, how many cells are required for 3 variable K map? We know it is 2 per n, so 2 per 3 is 8 cells are in K map. And limitations of K map, as we see already, and it is applicable up to 5 variable, and more than 5 variable we cannot go with K map. Thank you.